So let's do a mechanism here. Show all the products formed from the reaction of HCl with 3-methylpentane 2-ol. So let's write the structure first. Pentane 2-ol. So pentane 2-ol, and then I have a 3-methyl, and I'm supposed to be treating this with HCl. So I know that if I treat this with HCl, I have a few things that I should keep in mind. And those three things are that this is going to be an acidic mechanism because HCl is, of course, hydrochloric acid. The other thing is that I'm going to have a carbocation because I have a secondary alcohol. Because of secondary alcohol. So I'll have a carbocation, and as soon as I have a carbocation, I have to think about whether there is going to be a rearrangement or not. Okay, and finally my product is going to be a substitution product, okay, which means it's going to be an alkyl halide. All right, from there. So that's the way you make alkyl halides from alcohol, is by treating them with HCl. Okay, so those are all the things that I have to keep in mind as I'm trying to do this mechanism. So of course I will start with the alcohol because that's my functional group, and since I'm treating it with HCl, my alcohol is the base here, so goes for the proton. Once it goes for the proton, it becomes protonated, so OH2 plus. Okay, and so once it's protonated, it becomes water, and water, of course, as we know, is a great leaving group, so minus H2O. And the way that works is this. Okay, so the electrons go to oxygen and make the water go away. Once that is done, then this is the carbocation that we form. So here, keeping in mind that I'm going to form a carbocation, then I have to think about, okay, you know, can I make it more stable? So right now this is actually a secondary carbocation. So if it's a secondary, the only stable one will be a tertiary, okay, carbocation. So right next to it over here, I have a tertiary carbon, and so here I can move a hydrogen. So remember, for carbocations, you can have H shift, okay, which is called a hydride shift. So you can have a hydride shift, you can have a methyl shift, or you can have a phenyl shift. So here we don't really have a phenyl group, so we don't have to worry about it, but we do have a hydride, we have a methyl. If we shift a methyl, then the carbocation will move to the other carbon. A secondary carbocation gives another secondary carbocation. That's pretty meaningless. Okay, so the only thing that I can shift here is going to be a hydride shift. So that hydrogen is going to shift to this carbon, and once it shifts there, then I'm going to get my carbocation on this one. Okay, so now you don't have to draw the green arrow. Okay, that's just me trying to show you, but don't draw that out. Okay, because the right arrow is going to be the one that's in the red, and then here I'm going to go ahead and write that I'm going to do a hydride shift. Okay, and so then I still have the methyl group here. My hydrogen has shifted to the carbocation, which means automatically this carbon now is lacking the electrons, and so it becomes the carbocation. So now actually I have a tertiary carbocation, which is what I needed. Well, I didn't really need it, but that's what's formed. Okay, and so now all I have to do is finish off the reaction, and what's going to happen is I know that I need an alkyl halide. So here from the HCl, the chloride ion is still hanging around. Okay, and so that's my nucleophile. So now my nucleophile will react with the carbocation, and I will get the alkyl halide. Okay, now if you don't do the shift, okay, then you will get a different product. Okay, so let me show you that also. So if you don't do the shift, then you will just take this carbocation and you will think, oh, okay, you know what, I formed my carbocation, I'm going to go ahead and form the alkyl halide right here. But this will never ever form, because as soon as you have the possibility of forming a more stable carbocation, it will actually go for that. Okay, so you will never ever form this compound, not even minor, so you should not even write it out. Okay, so that's the most important thing when you form carbocations, is look for rearrangements and see if that's going to happen or not.